Okay, this video is about volume. So volume, you probably have all learned before. We're going to start off with what is volume. It's the amount of three-dimensional space an object occupies, or the amount of stuff in a container. So, it's three-dimensional, and that is volume. So volume is always going to be cubed because it's length times width times height. So if you have like 2 inches times 3 inches times 4 inches, that's going to give you 24 inches cubed because there is an inch times an inch times an inch. So it's going to be inches cubed. Or you could measure it in ounces if it's liquid, but everything that we do in class is going to be in units cubed. So, what is the difference between a line, an area, and a volume? I want you to pause this, think about it, and then come back. So, the difference between a line, area, and volume is that this is one-dimensional, an area is two-dimensional, and a volume is three-dimensional, just like we just talked about. So this could be like 3 inches. Area could be like 12 inches squared because it's length times width. Volume would be like 24 inches cubed. So that's the difference between a line, an area, and a volume. The area of a rectangle is just base times height, or length times width. Area of a triangle is 1/2 the base times the height, and the area of a circle is pi r squared. So those are just some areas that you should know. They're not too difficult, and you should have used them a lot before. So the first volume that we're talking about is a prism. So it says, here are some examples. How would you describe them? What do they all have in common? So basically, a prism is a shape on one end. So if we look at a triangle prism, it has a triangle on this end and a triangle on this end, and then it's like an elongated triangle. And then we have a rectangle and a cube and a hexagonal prism, a pentagonal prism. It's the same shape on both sides, and then it's just like this, and then those sides, and then it's just kind of like straight in between those two. So it's a three-dimensional figure. The way that you find the volume of a prism, if you think about it, all of these, I'm going to erase all of these marks. So we have that the base on all of these, so we have a base here, we have a base here, we have a base, let's say that one's the base, then we have this base and this base. So if we find the area of the base, and then multiply it by something, we could get the volume. So the area of the base times the height would give us the volume. Because it's like we're taking a shape, like a square, and we're just extending it like this. And then we have the same shape on the other side, like this. So this would be the base, and then we want to multiply that by the height. And that's exactly what this formula says. So the big B base is the area of the base. So if we had like in the area of a triangle, it's 1/2 the base times the height, but this base is talking about something different than this base because this is lowercase, this is capitalized. So we have all of that. So we take the area of the base times the height. So the first one that we're going to do is a rectangular prism. So which side is the base? On a rectangular prism, it doesn't really matter. So this side could be the base, This side could be the base, or this side could be the base. Doesn't really matter on here because it's like a rectangular prism. If it was a triangular prism or like a hexagonal prism, you would want the triangle or the hexagon to be the base. But here, let's just say that this side is the base. So if we look at this base, this is actually a square, but a square is a rectangle. So the area of the base, so I'm just going to do a capital B, that's 9 units squared. So in order to find the volume, we're going to do the area of the base times the height. So we would have 9 times the height, which would be this. So that would be 4 units, which would be 36 units cubed. Now, if we did this a different way, if we didn't say that this was the base, we could have said that this one was the base, right? Because it doesn't really matter. Okay, I'm not going to spend all the time to color that in. Let's say that this is the base. This would be 12. And then going this way, that would be the height. That's 3. So 12 times 3, that's 36 units cubed again. So either way, you get the same answer. So that's how you find the the volume of a rectangular prism. You find the area of the base times the height. That would be the volume. The next one is the volume of a cylinder. So it says, what is a cylinder? Here's a hint. It looks like this. And then it says, what are some characteristics of a cylinder? List some real life examples of cylinders. So I want you to come up with an example of a cylinder and write it down. So the first thing that I thought of was like a can, because that's, a pretty common cylinder. You could also do like a water bottle or a jar. There's lots of things that are cylinders. And based on what we just did, this is kind of just like a circular prism, right? So instead of it being like a rectangular prism or a triangular prism, it's a circle. So we're going to do it the same way, where this circle is the base, and then we just multiply it by the height. So the only thing that's different is that instead of finding the area of a rectangle or a triangle or something, we have to find the area of this circle. So remember, the area of a circle is pi r squared. So the volume of a the volume of a cylinder is just going to be that area of the base, pi r squared, times the height. That's exactly what it says right here. That's the formula. So cool fact, the area of a circle is pi r squared. The circle is actually the base of the cylinder. Instead of volume equals pi r squared h, you could substitute and write volume equals the area of the base times the height. What does that mean? A cylinder is really a prism with a circular base. That's exactly what I just said. So we're going to look at this cylinder, and we are going to calculate the area of the base and multiply by the height. So the base here, could it be this part that's going around? No, it has to be the circle. So I'm going to circle this. So that would be the base. So the area of the base is pi r squared. We know r is 3, so this would just be 9 pi. And we know that's centimeters squared. So to find the volume, we do 9 pi times 2, which gives us 18 pi centimeters cubed. And that is the volume of that cylinder. Okay, now the next one is a pyramid. So we just talked about how to find the volume of a pyramid like this. This would be the base, and then this would be the height. So a pyramid is basically, it has like a pyramid this pyramid specifically has the same base, the same area of the base, and the same height, but it doesn't fill up this whole container, right? It's just like part of it. So it says these two objects are the same height and the same areas of bases and the areas of the bases are the same. How many pyramids, so over here, how many pyramids do you think it would take to fill up the entire prism? And there's a cool video that I'm going to see if I can find really quick that actually demonstrates this. So okay, I'll try and find it later and I'll post it. But it actually takes 3 of these pyramids, the pink ones, to fill up the entire prism. And it looks like, to me, like when I first learned this, I thought it was like half, but it's actually a third and it works out perfectly. It's really cool to see. So I'll post that video later on the same page. So the formula for the volume of a pyramid is this part. That's just the volume of the prism divided by 3, or 1/3 of the base times the area of the base times the height. So remember, V stands for volume, H stands for height, the big B stands for the area of the base, and the little b stands for the side of the base. So over here, this is the side of the base. The example here says, now look at this pyramid, shade the side that is the base and calculate the volume. So we're going to say that this is the base because that's the base of the pyramid. It's at the bottom. So to find the area of this, we just multiply the 2 sides because it's a rectangle. So the area of the base is 4 times 10, which gives us 40 centimeters squared. So the volume, we're going to take 40, which is the area of the base, times the height, which is 6, and we need to divide it by 3. So 40 times 6, that's 240, divided by 3. That would give us 80 centimeters cubed. And that is the volume of this pyramid. Now the next one is similar, but instead of it being related to a prism, this is related to a cylinder. So we have a cylinder and a cone. This says, just like in the example before, these 2 objects are the same height and the areas of the bases are the same. How many cones do you think it would take to fill up the entire cylinder? Hint, it is the same as the pyramid and the prism. So we know that this is going to be 3. And then this says, remember, V stands for volume, H stands for height, and then R, that stands for radius because we're dealing with circles. So the R is going to be the radius. So the volume of a cone is the volume of the cylinder divided by 3. So pi r squared H divided by 3. Now if we're looking at this cone, it says the R is 8 and H is 5. So we have V equals pi r squared H over 3 for the cone. So I'm just going to plug in those values. So we have pi times 8 squared times 5. I guess that I don't need to have that in parentheses. So we have times 8 squared times 5 divided by 3. So this would be pi times 64 times 5 divided by 3. So all of this is going to come out to be 320 pi divided by 3. and that would be centimeters cubed. Or if we approximate this, if we multiply that pi in, that would be 335.1 centimeters cubed. And that's the volume of the cone. The last volume that we're going to go over is the volume of a sphere. So this is a sphere, and it says, what are some characteristics of a sphere? List some real life examples of spheres. So go ahead and write down an example or two. Some examples could be like the earth or a ball, right? Those are some examples of real life spheres. The formula here is 4/3 times pi r cubed. And this is cubed because we're in volume. So there's no other measurements that we're multiplying here. It's just the radius times the radius times the radius. So it needs to be cubed in order for it to be volume. If it was squared, it would be an area. So this is the volume of a sphere. And this says an official NBA-sized basketball has a diameter of 9 inches. What is the volume of that ball? So if the diameter is 9, that means the radius is half of that, which is 4.5. So the volume of an NBA-sized basketball is 4/3 times pi r cubed. And you can just type that into a calculator, and that'll give you that it is 381.7 inches cubed. And that's the volume of that basketball. And that's it for this video.